Good afternoon. We are really happy to have the opportunity today to tell you about Flowable in general, but also really about the event-driven improvements that we made recently. And Joram will show that a bit later in a very nice demo. So I have here with me Joram Barrez and myself, Tijs Rademakers. We both work for Flowable. We both have a background also in Activiti. So we basically continued all the work we did with Activiti in the Flowable project. So it's really a continuation of Activiti. And Joram also has a background even in the JBPM days. So he's there already for a long time. So what we will do today is focus really on the event-driven features that we added recently, and also the MyMan engine improvements and features that we built recently. Because if we would focus really on Flowable in general, 45 minutes would be definitely not enough. And even a university session would be really difficult to squeeze everything in such a session. So we will be really focusing on the event-driven part, but also give you a little bit of introduction into Flowable in general in the first slides. And hopefully you will be inspired to look a little bit deeper afterwards into the Flowable project. So you can always go to flowable.org, download the latest stuff, or go to the GitHub page and check it out. So some facts and highlights about the open source Flowable project. We really focus on the BPMN, CMMN, and DMN open standards from the ONG standardization organization. And the focus is really to make them high performance, scalable, and ready to be used in production. And a really important part for the Flowable project is the community. So we invest a lot of time in answering forum posts, in helping creating PRs, all that kind of stuff, writing documentation. And we are really happy to see that the community is growing nicely over the years. So a little bit of indication, we now have around 2,300 GitHub stars, and that went up really nicely in the last 3 years. So we are really happy with that. So the open standards that we implement are really important, are really key for the Flowable open source project. So we have the object management group, the OMG, who defines a lot of standards, including BPMN, CMMN, and DMN. So BPMN is business process management, business process model annotation. It's really focusing on the process side of things. That standard has been around for quite a while already. So that has really proven itself already for a long time. CMMN has been added more recently, so that really focuses on the case management side of things, and DMN focusing on the decision stuff like rules and all that, which is the most recent standard. And interestingly, those standards, mainly BPMN and CMMN, mainly focus first on only the visual representation. So that was really the start to have a common language to model your processes and cases. But more recently, the XML definition has been added to these standards as well, which is really important for us, of course, because we use these XML files to parse them and run them on our engines. So the combination of the visual representation and the runtime execution of those standards, that's what we do in the Flowable open source project. And the really nice thing is that you can use these standards standalone. So you can use DMN as a rules engine just in your application without using BPMN and CMMN. But it's really, really key and really important that you can also use them all together. So we have CMMN as the case kind of view that could trigger off processes when you use a user event listener in CMMN, for example. Or you can use a DMN rule service in a process. So you can really use them all together. And it's also possible, for example, to create a subcase in a process, which is maybe a bit less common. You would normally do it more the other way around, start a process from a case. But there's a lot of relationships you can do. And really the breaking up your complex model in one part, the CMMM model, and multiple process models, really makes your modeling exercise also a lot easier. It really puts structure in your modeling. So that's really a nice benefit. And that's actually also the hardest part of all this. So you have some requirements that you want to fulfill, creating a business process, and translating these requirements into a solid model. Also breaking up the model maybe in sub-process models and sub-case models. That's really the difficult part in this, and which requires domain knowledge, of course, talking a lot between business and IT. But it also helps a lot because while modeling and while creating this model together with business analysts, designers, developers, you actually also create a kind of common ground with each other. These people all know the specification, all know how to interpret a CMMN or BPMN model. And this is also a way how you can collaborate in an easy way with each other. You can really discuss, should this user task have a boundary event? Because, for example, if that user task is not completed within 1 day, you should have a kind of escalation path in your model. That's the kind of stuff you can express there easily. So the starting point is really to have a model-centric starting point in all of this. That's really key in Flowable. So it's a visual representation of your business requirements, which is understood then by both analysts and developers or business and IT. And the really nice thing is that the logic that you have within that model is really expressed, and you have a picture explaining it. So your orchestration logic is not hidden in any code. It's really expressed in your model that you can share in a document, but that you can also share in a lot of other different ways. And another really nice benefit is that with that model, it's not only the modeling exercise you do up front to translate your requirements into a nice model, but actually while running that model, you can also show a nice runtime overview of that model. So you can show which are the current activities that are active. What is my current state of this process, of this case instance? But it can also show you the completed activities in a good way. So it already provides a good overview of which path has been followed in the process or case instance until now, which is really valuable. And together with that visual representation, there's also a lot of state data, like variable data, identity links, like groups that are tied to your process instance or case instance for permissions, that kind of stuff. So that combined gives you a really good overview of what's happening in each instance. If we take a little step back and look at the Flowable architecture, we started off a lot of years back with just a BPMN engine and a couple of applications like the modeler and task application. And that BPMN engine had everything inside it. So it had a variable component, it had a task component, a job component for asynchronous and timer jobs. But then we built the CMMN engine and we built the DMN engine, and we extracted a lot of these things in separate services. So now inside Flowable, you will see a task service, you will see a variable service, a job service, and a couple more, which are then reused across all engines. It's like a common ground for all the engines we have. And that's on one side, it makes it really reusable and granular, but we did it in a way that it's not more complex. So from a developer and user perspective, it's not more complicated than before, but it's now nicely broken up into different services. And also the persistence layer is fully pluggable. So we did a proof of concept to store the process data not in a relational database, but in MongoDB. So we totally replaced the relational persistence layer, and that's just possible. We only needed to re-implement the persistence logic, and everything was still running exactly the same. No changes were needed on the high-level API. So that's from a Java API perspective. But what we try to do is really have a REST API which is on par with this Java API. So if you want to query process instances, case instances, get variables, get whatever you want, tasks, it's all possible also with a REST API. So we have a Java API which can do this as well, of course, but there's a rich REST API for all this as well. And what we also really spend a lot of time on is Spring Boot support. So we try to make it really convenient to use Flowable within a Spring Boot kind of setup. So we have a lot of starter modules, with the one at the right top as the main one. So the Flowable Spring Boot starter, which just gives you all the engines of Flowable. So everything is just available for you directly within a Spring context. You can just inject the Flowable services directly in your application logic. Nothing is needed to be done for that. That's just working automatically. And also auto deployment. You can just include process files, resources, case resources, decision resources, and they will get auto deployed on the engines at boot up for you. And at the right bottom, you see a small example what you can do with just adding the dependency to the Flowable Spring Boot starter project module. Here you can see that it exposes a REST endpoint assurance claim, and that kicks off a process instance with some variable data. And it's just a simple class and nothing more that you have to do for it. So before we go really into the event-driven stuff, I want to give you a small introduction in BPMN and MyMan, just for the people that are not familiar, maybe with MyMan mostly. So BPMN is really flowing from one activity to the other. So you see, for example, a lot of arrows, which are sequence flows in BPMN, and you just connect activities to each other. You always start with a start event, you end with an end event. We have a user task, which represents some human work that needs to be done. You can have a service task, you can have an email task. And there's an exclusive gateway, for example. There's also parallel gateway, inclusive gateway, but an exclusive gateway that allows you to have some kind of if logic in your process. So this is really a very simple set of BPMN elements that you can use while modeling. There are a lot more, of course, but yeah, this gives you already a nice palette to work with. MyMan is maybe a bit less known. It works in a bit of different way. So you don't see sequence flows. That shows the flow of a process or case in a first view, but you have the concepts of sentries. So you see the kind of diamond-shaped elements there, and that's a sentry, where you can say, for example, from stage 1 task to stage 1 task 2, there's a sentry, which means that when stage 1 task is completed, then stage 1 task 2 will become available. So in that way, you can still connect elements to each other, and you can still have a kind of sequence in your elements. But what is really the power of MyMan is that you can have a lot of stuff happening on different levels. So in this case, we have 2 stages, but we also have a user event listener, which goes to an exit sentry at the right top. And you can always trigger this user event listener at any point while executing this case instance. And that would be quite hard to express in BPMN. You would probably need a kind of event sub-process or something. But MyMan makes this really easy. So you can just add a user event listener or another kind of event listener type and connect it to an exit sentry, which means that this case instance will be terminated when that user event listener will be kicked off. So it's a lot more event-driven how MyMan works. Now Joram will continue with the event-driven demo.
Right, okay, this thing is on. All right, thank you for warming up the crowd. You did a great job. All right, so for the remainder of this presentation, we will focus on the event-driven architectures and how to integrate Flowable in these architectures. And if you look at the schedule of DevOps today, you see that a lot of people are talking about it. And you also see that people in our community, in the Flowable community, they are experimenting with it or maybe already using it. So it makes sense to really look at it and see how we can improve it. And if you think about it, a process or a case fits very naturally in these kind of event-driven architectures. The process or case, as Tijs was just showing you, they can be the reaction on a certain event. They can be, if you're talking about event sourcing or you're talking about CQRS, they can be the command that you execute when something comes in. And one of the hard parts about event sourcing or event-driven architectures is that you need to have state. You got an event in, and you got to apply that event to some state. So you got to build up that state somehow. And that's something, as I will show you in the demo later, that you get implicitly by using a process or a case, because it's already there, and you know the context of in which it happened. Now, to get our heads in the same direction, I will switch quickly to the design environment, and just to show you some concepts, so we're all talking about the same thing here, right? So I'm going to switch to our modeling environment. And what I'm going to do is I'm going to create a simple test process. Whoops. I've got one of these broken MacBook keyboards, as you notice. It's not funny, you should laugh. Here we go. All right. So this is just a standard empty canvas. So I'm going to remove this little guy here. We don't need him right now because we're going to start with an event. So we're going to say we want to do something when an event comes in. So we can configure this guy here if we want to. We can click on this and say, okay, there's a couple of events that I've got ready for the demo, of course. So we can select, for example, a document was created. And we can do a few things here. What we can do, and I don't know if that's visible, so I'm going to try to zoom in here. Here we go. What we can do is that when this event comes in, we want to start a new instance. So whenever this thing happens, we just kick off this process. And as you can see down here, there's data in the event, obviously. There's data in the event that gets transported over Kafka, for example, as we'll use in the demo today. For example, this particular thing, it has a folder ID and a document name, and then we can inject that into the runtime instance. Right, so imagine that this event comes in into some kind of queue or an event stream, and what we want to do is we want to do two things in parallel. For example, here we want to say, let's make this parallel. This is a parallel split, so things will happen now concurrently. We want to do something, we want to have a user fill in a form, right? This is expressed this way, and we want to do something automatic. We want to call out to a REST service, for example, and here we go. So in this case, what we modeled is that event comes in, two things happen in parallel, one for a user, one for a service. Now it also works like this. So if I now drag what's called an event boundary event onto this task, we can say, okay, that's fine, as long as this person has not done the job, the task is in the task list, and an event comes in, we want to do something. This could be, somebody has picked up the phone, there's an escalation going on, there's panic, let's destroy this task, let's remove it, and now let's here escalate with this task, right? So, I mean, this is just a very just touching barely what we can do with it, but I hope you get the idea of, including these events in your processes and cases. And switch back to the presentation mode. There we go. Now, before we go into the code, we would need to talk first about some concepts that we've added to the engine recently. One of the things is the event registry. And as the name implies, it's a central location, central repository for what we call event definitions. And these event definitions, what they basically do is they describe your event. They tell you what's the structure, what's the kind of data in there, the types, and stuff like that. Right now, that's our own thing, but we can easily plug in any kind of standard that would come out. And there are a few things going on right now where we can plug in and read these kind of event definitions from a central repository. Another thing we added is the event bus, and people that know some design patterns might recognize this. It's a standard kind of way of registering consumers and producers in a kind of generic way without them knowing each other. Okay, so we've got this event registry, we've got this event bus. Another concept, two concepts actually, that we added is channels and pipelines. So every event comes in through a certain channel, right? And that channel, that's being listened to by something that we call an adapter. So for example, if we're using Kafka in the demo later on, there's a channel adapter for Kafka that's listening to these events coming in. At that point, the event will be passed into the event registry, and the event registry will know, okay, this is the pipeline associated with this particular channel. So what happens then is we go to this inbound pipeline. And by default, because I say by default because every step that you see here on the screen is pluggable. I will show you that later on too. Is every step here can be plugged in with your own things if the default is not okay for you. So what we do when an event comes in by default is we deserialize it first, of course, because you got some raw bytes coming in, so to say, and you want to map it to JSON with Jackson, for example, you want to make XML out of it, whatever you fancy. Second step is we need to know, okay, what events are we handling? So that's the second step is called event key detection. That's what we do there. And once we know the event key, the key is a unique identifier. Once we know that, we also know, okay, go and look in the event registry and see the kind of payload that we expect and accept in our processes and models. And that's what you saw also when I was showing you the model just before. And last step, we're transforming it into some internal representation, giving it to the event bus, and then the consumers can do their work. And we have out-of-the-box consumers for the use cases that we support right now, like the boundary I just showed you. The other way around is quite simple. So you produce an event and it needs to go out to some channel, right? So just the other way around, you produce an event, goes to the event bus, event transformation, get some serialization, of course, depending on the type of queue you're sending it to, and you send it out to a channel adapter. All right, so we've got the concepts in our heads now, and we can have a look now at some actual code. Everybody's been dying, I can see it for that. And if you're interested in that, all the code that we will be demoing today can be found on our GitHub repository on the URL right there. The use case that we're going to show and we're going to show the code for is the fictional company doing electrical kick scooters. And if you live in Belgium like I do, and you live in a city that wants to be named a city, then you probably have at least 3 startups right now, doing these electrical kick scooters. So we're going to build the software for them, and we're going to focus on customer satisfaction. That's the #1 priority for this particular startup. So what we're going to do is customers, they will be able to provide reviews. They're going to rent this little kick scooter, they're going to drop it off somewhere, and then they're going to use their phone to basically send a review of how happy or unhappy they are with the kick scooter. These reviews, they will be pushed into Kafka. There's going to be a couple of topics right there, and we're going to push the messages, the reviews, into them. And then we're going to have a customer case. We're going to have a case for each of our customers that will come in, and it's going to be used to kind of manage the relationship with the customer. So all the reviews will come in. We will all group them. They will always be there. And that's one of the things that the case management, or CMN in this case, is very good at. It's very good at keeping everything in the same context together. So you can look at the case and you can see, oh, these were the reviews for this particular customer, and way more, as I will show you in a minute. When the review comes in, we're just not going to store it. We're also going to kick off a sentiment analysis. Now, that sentiment analysis is implemented using a BPMN process, and we're going to use AWS Comprehend. So AWS Comprehend is a service from Amazon to do sentiment analysis. You send it basically a blob of text, and it's going to tell you, okay, this is a happy text or this is an unhappy text, right? And if there's a bad review, we're going to create a task for our employee to kind of massage the relationship back to health. Maybe send out a tweet. You've all seen this, right? Or maybe send a gift. I don't know. All right, let's talk a bit about the architecture. So, of course, fundamental or foundational to all of this is the kind of Kafka queue, the kind of Kafka event stream that will be transporting all of the events that will happening. And our story starts in the top left corner with a UI for our customers. And I'm just going to show it to you. Now, don't peek if I go into PowerPoint now. Don't. All right. Yeah, you did it anyway, I saw. All right. So this is a React application that we've written. And basically what we've done is we've taken the data, the open data, from the London Santander bike system. And what we've done is we put this on the map, as you can see, and each one of these points, these blips on the map, they are a station where somebody can drop off our kick scooter, right? So what we can do is we can click on one of these and we can send in an event, right? We can send in a review, which will translate to an event behind the screens, right? So that's the kind of UI that we're working with. And what we've done also, there is some random data going on here. So what we've done is we used fake names, but we've scraped some real reviews from TripAdvisor and used them as kind of data for this particular demo. All right, so keep that in mind, don't peek. Again, yes, very good. All right, so we've got this UI. People will be using this to send in the reviews. At that point, these reviews will be pushed into Kafka. So we have a review service that is built with Spring Boot's Project Reactor and Spring Wet Flux to push these reviews reactively into Kafka. Now, once we've got these reviews, we have our customer relationship service. Now, this will be the meat of this demo because this is where the case model will live, the process will live, and it will react onto any review coming in. So whenever there's a review coming in, we're going to do something with it, and I'll show you that in a second. Now, one of the things that this application will do, it will produce new events. It will need sentiment analysis, right? We want to know whether or not this is a good or bad review. So it's going to send off an analysis request, again, back into Kafka. And there is another service listening to this particular event. So this is the sentiment analysis service. It's again a Spring Boot application. It's going to listen to these events. It's going to kick off, it's going to call out to AWS Comprehend to get the actual sentiment analysis, and it's going to push back the result. Right? And of course, the central application is again listening to it. And we also have for our employee the Flowable task application that is using the same Postgres database as the one in the middle, right? So that's kind of the architecture that we will be working with, and I'll be showing all the parts of this thing to you in a few minutes. Now there is a fifth service here, which is not on the slide just for simplicity reasons, but it's there in the code, so I'm going to mention it. There is a Spring Cloud API gateway, basically to avoid that we have to interconnect all these things and there's just one gateway to talk to. Doesn't change anything about the story, but just so you know. All right, let's dive into the model, because of course, big part of what we're going to do is we're going to create this model, we're going to have this model, and we're going to put it into a Spring Boot application to actually listen to these events and act upon it. All right. Let's go back to our modeling environment. Yes, we can ignore this guy. Here we go. Right. All right. So this is the case model. It's simplified for demo reasons. It can be way bigger if you want it to be, but at least it shows some interesting things. First of all, we're going to have to configure how to start a case for a new customer, right? We have a review coming in and we don't know who is the customer. It's a new customer. So what we're going to do here is we configured it to listen to a particular event, namely the review event. And it's different from before, right? Before, we had start new instance here. It's still there, that option's still there. But right now, what we say is that if we detect that it's kind of a new kind of piece of data, and we can know that because we've got the event data, start a new instance, only if there's no other instance existing. So that means that we only have one case per customer. That's what we want. Now, the event only also exposes some data. In this case, as you can imagine, it exposes data about the user. It exposes data about the station, that the review was happening, the rating, and the comment. All right. Now, that was about starting it. And this part here, this is quite interesting, because if you look here, what's happening here is that the moment the case gets started, we go into the customers in an active subscription, right? From that point on, we listen to these events. We listen to reviews coming in. So every review coming in for this customer, we're going to handle it within this case, right? Now, this is kind of like, if you know IFTTT, it's kind of like this pattern. You say, if this happens, then do this. This is kind of the pattern that's modeled on the top here. So what we do here is we say, if this event comes in, there's a new kind of UI here. And let me, again, zoom in a bit. So how do we now know which case to trigger or which process? Because the same story applies to our process engine, of course. How do we know we've got this case running, this event comes in? How do we now know, okay, this data this event data applies to this case? Well, for that we have the correlation parameters. We say now, the moment the engine arrives at this step in the case of the process, we're going to look at the correlation parameters for the event that's been configured behind the scenes. I'll also show that in the code. And what we're going to do is we're going to generate a kind of a unique hash out of that. And that's going to go in the database, can be there forever. When the event comes in, we're going to do the reverse kind of thing, or we're going to do the same thing, to generate a hash, and we're going to look up, okay, who's listening to us in a very kind of performant, efficient way. That's pretty cool code if you want to see that in the engine. And again, this has data that we push back into the instance. So this case will contain all the data at this point. And what we're going to do, I mean, there's a lot of things going on, like we're going to handle some support requests, we're going to handle deactivation. That's not really important for this demo. We're also going to send the user an email every anniversary of his subscription. We're going to send a nice email thanking him, as a typical startup would do, thanking him for the usage of our awesome bike service the last year. And there's people like you, the dear beloved users, that motivate us to continue, yada, 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 All right, so review comes in, and we're going to kick off this process. Now, the process is quite simple. It's basically sending out, remember the architecture slide, sending out the event for analysis request, waiting for the result to come back. If it's a negative review, we create a little task, and we reach out over Twitter. That's what's happening here. So that's nothing special. This is a process. Now, we'll talk about this step because you might have some questions. We'll talk about this step later on in the slides. All right, now I'm going to keep PowerPoint open because I'm going to have to switch between IntelliJ and PowerPoint, and it's going to be quite annoying if it always goes black. So I'm going to do it like this. So first of all, let's run all of this. So what I've done just before this talk, I've cleaned my environment, so it's quite dangerous, cleaned my environment and booted up all the services again. So what I've got running here is Zookeeper, Kafka, the front end's running here, and here you can see I've got the 4 services already booted up for you. So what I'm going to do now is, you might have seen before that there is a little window here. You might have seen there is this settings, right? Right now we've frozen the mist of time and we're waiting for input. So what we're going to do now is we're going to switch to a lazy Sunday morning. People are going to come in, are going to wake up. They're going to go to the bakery, maybe buy a newspaper. But traffic is light, and you see that slightly. Here we go. There's people writing reviews, but it's not particularly busy right now, right? So basically, we also made a nice kind of dashboard because, of course, people like moving things and pretty graphs. So let me switch then. Here we go to this. So you can see that things come in. There's a little counter here about the review events. We also see there's all of them are pretty much new customers, obviously, because we booted up from a clean environment. There's an equal amount of case instances as there are reviews coming in. There's 10 of them who have sent in a bad review. So that's just continuing as we go. Now, just to give you an idea what how this would realistically look like, we looked at the numbers of the actual Santander bikes and then divided them by hourly and made a calculation about what would be real. So we call that the frantic Friday evening. Work is done. You want to go home. You want to go to the bar, and people are using our kick scooters like crazy. So they are sending in reviews. Again, what's happening here behind the scenes is these reviews get pushed in reactively into Kafka. There is a case listening to all of these reviews. We're gathering these all by customer, and we're kicking off the sentiment analysis on AWS Comprehend at the same time. All right, let's freeze the mist of time. And of course, I should have shown you this, that by now our dashboard has caught up with the kind of things. And let me do it again, because otherwise the people that have written this will complain that I didn't show it properly, because actually it moves. So if I do this again, right? If I do this again and we wait for a few seconds, you will see that it moves in a very nice way. All right. So that was the kind of automated simulation. So let's now do a review ourselves and see the kind of code that we hit every step of the way. Okay. So what I'm going to do is I'm going to click, this is my favorite drop-off station. I'm going to say, this is me. I really did not like this particular kick scooter. This is a bad service. You might notice again the 2 spaces here due to my broken keyboard. Okay, so if I would submit it now, what would happen? Right, so we're going to push that, remember architecture, we're going to push that into Kafka in a reactive way. So let me show that how that looks like. That's pretty straightforward code. All right, hope this is big enough. Very simple Spring Boot application. We're configuring the Kafka sender with some default parameters. We've got a Spring Wet Flux. Come on. Yep. Here we go. We've got a Spring Wet Flux kind of endpoint. Only has one method where we send in the reviews we receive from the UI into Kafka. And then we've got the actual, that was already the service. And then we had the Wet Flux REST controller who just passed it to the review service in a reactive way. So there's nothing special about that, but that's just pushing those events, those reviews into Kafka, right? Now we come to the meat of this thing, right? The customer demo. I showed you the model before. This model, which we actually did, right? So this particular model, no, this particular model. What we actually did is we exported this and put it on our class pod. So if I go to the customer case application, here we go. It's again a Spring Boot application. It has the Flowable Spring Boot starters that Tijs talked about as a dependency. And what's there is on the resource, you can see it has a few folders. It has cases, it has the processes, and it has the forms. So what happens if this application boots up, our Flowable Spring Boot starters will notice that the application is booting up, and it will check these folders for any models, the one I just showed you, that are there. If there was any models there, they're going to be deployed, and from that moment on, the moment your Spring Boot application has booted up, it is listening to those events. It's ready to receive those review events and the other events, and it's going to start working. There's nothing you need to start. I can't show you any API call as usually we do in these presentations, because simply it works because it's modeled, right? It's simply there. Now, what else did we need to do? Let's get back to that configurator in a second. We need to configure those channels. Remember, we talked about the channels and the pipelines before. So what we need to do is we need to tell, okay, what are we listening to? And that's quite simple, actually. So we've got a simple channel adapter. Remember, that was a channel adapter in our previous slide that was listening to the events coming in. And we're using Spring, so it's quite easy. We just say, okay, this is a Kafka listener. And if something comes in on this particular topic, then we do something. There's also the little event counter here. That's the one that was populating the dashboard that you were seeing in the moving graphs. All right. So that's and the other way, we also have the out. I mean, this is the out one. Nothing more than simply the Kafka templates and a topic, and the work will be done in this abstract superclass. I mean, there's really not much to it. It's sending out this event, right? So that's what's happening with the channels. Whoops, that's the wrong one. Here we go. So beyond that, we don't have anything else except, of course, how do you configure these events? And that's, of course, where it becomes interesting. So let me show you how you configure these events. And this is like an API. That's a builder API that kind of allows you to build these things really nicely. So what we say here, this is for the review events coming in from the UI. So what we say is there is a channel, has a name, is listening to a certain channel adapter. In this case, it's Kafka. And we say it's JSON. So we serialize the bytes to JSON. We only have one event type coming into this topic. So fine, that's fixed. And we map them. Now, this is, of course, the default one. If you don't like them, there's a couple of ways where you can basically plug in your own event processing pipeline if you just want to rip out the whole default and replace it fully, or you can actually have more options along the way here saying, okay, it's not fixed, but it's in the JSON itself. It's basically in a JSON pod expression to get there. So that's the channel. And then we've got the raw event. So basically what we then say is, okay, this event, the review event, comes in through the inbound channel, the review channel from Kafka. And these are the things, remember, the correlation parameter, payloads, that's the things that we had, if we go back to this UI, the things that we had in this particular UI, right? So that's how it's populated. Now, this is the programmatic way of doing things. And of course, we will also have a way of doing this declaratively, where you can deploy these to the engines without having to replace all these things. And all the engines in a cluster pick it up easily, and they can talk to each other. And all the things you are used to from what we do. So that's the kind of case application, the customer case application. And I've said everything I need to say. There is another kind of thing that I wanted to talk about, is that I told you that in this particular process, there is this send and receive, right? So this particular process has two events. It's going to send out the analysis request, but it's going to wait for the result to come back. And many people that have tried to model this in Flowable have modeled this in this way, where you send something and where you're waiting for it to come back. Now, there's a bit of a race condition here, because if this transaction, your engine's still executing, this transaction is still busy, and you're sending off to a queue at that point that you hit the send, that queue or whatever is on that queue is very fast, comes back immediately for some reason, then it could be that simply the transaction is not committed. If you've got a slow database or there's a lot of load, then you can have a problem. So to fix that, we kind of built what we call a triggerable service task. The triggerable service task, basically, the long story short, is that solves it for you. The longer technical explanation is that what we do is during the original transaction, during the execution, we create what we call an event subscription. We create an asynchronous job containing the information to continue later, but then we commit the transaction. In the post commit, we give a little kick to our job executor. It's a component that will pick up this job, which will send out the event, and then the process or the case will go into wait state. Then in the, later on, when the event comes in, we know it's all there, and it can trigger the right thing. So long story short, again, is use that triggerable service task when in doubt about these race conditions. Another question you might have is, of course, I said that this particular application is reactive, so that the pushing of events into Kafka is reactive. Can we make the pulling or the consuming of them also reactive? And the answer is yes. Well, the answer is yes. If we would have started a week earlier with work on this, then we probably would have been able to show you. We know exactly how to do it. We know that when the event comes in, we pass it to the event registry. Then we need to create an asynchronous job, probably using R2DBC to kind of do that reactively. But that's basically the whole thing that we need to do. So keep an eye on our blog for the next coming weeks, where we hopefully can talk about these things. Excuse me. All right, so the last part, I forgot to click on submit. Nobody told me. You should have told me. The last part was, of course, clicking submit, because this is a bad review and we're submitting it. So what happens now is that, remember that the events come into the case application, we're sending in this analysis result, and the sentiment analysis application here, and I don't know if that's visible, but basically here, we're calling out to AWS comprehend, and this is what AWS comprehend returns. It says is a negative review, right? That's quite obvious, but it still said it. And let's have a quick look at that application. Again, it's a simple Spring Boot application with the Flowable Spring Boot starters as a dependency. It again configures some engine events, like the one I just showed you with the channels and the event definitions. There's an adapter for both the incoming and the outgoing, and there's two beans, the random sentiment service and the sentiment service. They are referenced in the process. They are referenced, where are they here? Sorry, yeah, I should have gone to the I was in the right spot. Here, no, I am not. Oh, that's because I'm not in the wrong, here we go. So, surprise, the actual sentiment analysis is again done with the process. And what's happening here, right, is that we're waiting for this request to come in. And to avoid, when I was having this Frantic Friday setting, to avoid that we would have great or huge Amazon bills, we kind of made a little cheating here. What we said is that if one of the people doing the review, it's me, Stat, or one of our other coworkers, then we go to Amazon. Otherwise, we randomly generate that, because that adds up quite quickly if you just keep pushing it. So right here, we're going to Amazon, and we're calling out this to the sentiment service bean, basically. And this sentiment service bean, let me just show you real quickly, looks like this. This is using the Amazon SDK, the Java SDK, to basically, very simply send out a request for a certain sentiment, and it comes back. Now, if we think about this particular service, let me make it a bit bigger, then you might notice that the receival of this event, kicking off the sentiment analysis to Amazon Comprehend, is effectively a function. It starts with input and it produces an output for you, right? The output being sending out the event again. That means that you can run this serverless, in a sense that you only pay for whenever this event comes in and you want to do a sentiment analysis, and you don't need to keep running it all the time. Now, we've done some experimentations with this a couple of months ago, and if you want to read all about this, there's the link to the blog right there. Is what we've done first is we've taken, kind of this application, and we've put it into Amazon Lambda using Flowable and Spring Cloud AWS. Now, that was quite straightforward. And then we went further, and we looked at using Flowable plus Spring Foo and GraalVM to compile a native image containing only the full-fledged process engine, let's say containing the full-fledged process engine and only a process that was ready to go whenever you hit an endpoint. That was successful. And then also we looked at Micronauts with GraalVM. It boots up in 30 milliseconds. So in 30 milliseconds, you have this full-fledged process engine running or ready to receive an event or receiving something on HTTP gateway and then starting a process. Now, the last thing that I wanted to show you is, of course, we had a bad review. So the last thing I need to show you is that when this comes back into our, here we go. When this comes back into our sentiment analysis process and it's a bad review, what we do is we create this task right here, the handle negative review for our customer. So if all went well, this is the open source Flowable task environment, by the way. If all went well, there should be, here we go, there should be a handling of that I, Joram, has written following bad review that this is a bad service, and then we can fill in and basically a response, and we can then send it out to Twitter. Now I'm not going to do this for real, so but the typical kind of big companies reaching out to you on Twitter, dear valued customer, etc., etc. Valued. Right. I'm gonna. This is a developer conference, so let's not go there. But that's basically how then you can push it into Twitter or whatever you want to do. So I think that was the last kind of thing I wanted to show you. And basically, I hope the kind of, there's as Tijs was saying, there's a lot in Flowable. There's really a lot in Flowable. We can easily fill a 3-hour slot just by talking about the basics. What we kind of want to get across is that it's a lightweight, kind of versatile open source framework for doing processes, workflows, case management, business rules, and stuff like that. And what we really want to focus on today is that it is really easy to use Flowable in your event-driven architecture. As I showed you, you can model these events really easily visually. You can define the behavior associated with it. You hook it up with some Spring Boot application, and you're ready to go. Quite powerful, quite easy to do. And with the benefits, of course, that you can have these models together with your business analysts and discuss them together, because that's the hard part about many people's job. I've been there myself, is how do you, get all these requirements then needs to be typed out. And there's always discrepancy and always discussion. And the model at least solves many of the issues. And that's really what Flowable is all about. And there's way more. If you want to know more, you can always come down and talk to us at the booth. So if you come, we are, when you enter from the outside, when we enter on the left-hand side, that's where we are. You see our flag straight away. Or if you don't know what to do, next Friday, we are organizing a community event in Germany. There's still seats available if you want to, and otherwise we'll squeeze you in. And let us know. Thank you very much for your attention.